Assalamu alaikum everyone. Today we are going to learn how to show that the quadrilateral is a rhombus. So a quadrilateral is a rhombus if all the side lengths are equal and the opposite sides are parallel. So to check that the quadrilateral is a rhombus, we need to do two steps. In first step, you have to find out all the side lengths and that must be same. And we need to find out the slopes of opposite sides that must be equal. Okay, let's do an example. Show that the quadrilateral having coordinates P, Q, R and S is a rhombus. So we have given a quadrilateral P, Q, R and RS and we have to show that it is a rhombus. So we have to do basically two steps. So in step one, we have to find the side lengths of all the side lengths and that must be equal. All side lengths are equal. Okay, now how do we calculate the side lengths and what does it mean that side lengths are equal? So let's start with the P. So the length of PQ, the side PQ, must be equals to the length of the side QR. That must be equals to the length of a side RS and that must be equals to the length of a side SP, right? Okay, so for the length we have to use a formula. I have explained you in one of my video the length of a side, or we can say that the distance between the 2 points, its formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Okay, now let's calculate the length of all the sides one by one and let's see the side lengths are equal or not. Okay, so let's begin with the length P and Q. Okay, so you need to label the P coordinates as x1, y1 and the Q coordinates as x2 and y2. So it would be square root of x2 minus x1 whole square. So it would be negative 30 plus 5 whole square plus y2 minus y1 whole square. So that would be 10 plus 5 whole square. Okay, so we have negative 30 plus 5, that would be negative 25 whole square, plus 10 plus 5, that would be 15 whole square. Okay, so it would be equals to square root of negative 25 is 625 plus square root of 15 would be 225. And that is equals to square root of 850. So we have got the length of a side PQ, that is square root of 850. Let's do the next one, the length of a side Q and R. Okay, so you name the coordinates of Q as x1, y1 and the coordinates of R as x2 and y2. And let's put the coordinates into the formula x2 minus x1 whole square. So it would be negative 5 plus 30 whole square plus y2 minus y1 whole square. So that would be 25 minus 10 whole square. Okay. So that would be 25 whole square plus 15 whole square. That is again equals to the square root of 625 plus 225 and that would be equals to square root of 850, right? So the second side length is also equals to the first one. Let's go to the third side length. The third side length is a side RS. So you have to name the R coordinates as x1, y1 and the S coordinates as s2, x2 and y2. So it would be a square root of x2 minus x1 whole square. So that would be 20 plus 5 whole square and y2 minus y1 whole square, that would be 10 subtract 25 whole square, right? Okay, again 20 plus 5, that would be 25 whole square, and plus 10 subtract 25 is negative 15 whole square, and square root of 25 is again 625, and square root of negative 15 would be positive 225. We need to add both of them, and that would be equals to 850. Right, we have got the third side length also equals to 850. Let's go to the last side length, that is the length of S and P. Right, now to find the length of S and P, we have to name the S coordinates as x1, y1 and the P coordinates as x2 and y2. So we have a square root of x2 minus x1 whole square, that would be negative 5 and negative 20 whole square, plus y2 minus y1 whole square, that would be negative 5 and negative 10 whole square. And that is equals to square root of negative 25 whole square plus negative 15 whole square. Right, and that is equals to 625 plus 225. And when you add both of them, we have got the same side length, that is equals to square root of 850. So we can see that all the side lengths are same, that is square root of 850, right? So we have done with the step 1. Let's go to the step 2. Okay, in step 2, what we have to do, we have to check opposite sides are parallel. Opposite sides are parallel. Okay, now what do we mean that opposite sides are parallel? So opposite sides are parallel means opposite side slopes are equal. So means the how do we say that opposite side slopes are same? So we can say that the slope of a line, slope of PS must be equals to the slope of Q and R, and also the slope of PQ must be equals to the slope of SR. Okay, let me show you. Let's go to the figure. So the slope of PS and QR. So we have the PS and its opposite side is QR. So we can see the bottom one is the PS, this side is PS, and its opposite side is Q and R. So we have the P and Q and its opposite is R and S, right? So now let's find out the slope of the points, right? Now when we have given 2 points, how do we find out the slope? We have to use a formula, slope equals to y2 minus y1 over x2 minus x1. This formula we have to use when we have to find the slope between 2 points, right? Now let's begin with the slope of P and S. Okay, so P coordinates we have to name it x1, y1, and S coordinates you have to name it x2 and y2. So y2 minus y1 whole square, that would be 10 plus 5 over x2 minus x1 whole square, that would be 20 plus 5. So that is equals to 15 over 25, and in the lowest form it would be 3 divided by 5, right? So we have done with the slope of PS. Now the next, it must be equals to the slope of QR. So you have to name the Q coordinates as x1, y1 and R coordinates as x2 and y2, right? Now let's find out the slope y2 minus y1 whole square. Sorry, y2 minus y1. So that would be 25 subtract 10 over x2 minus x1, that would be negative 5 plus 30. So again This is 15 over 25, and in the lowest form that would be 3 by 5. So we can see that the slope of PS and the slope of QR is same. Let's see the slope of the two opposite sides. Now the slope of PQ. Slope of P and Q. Now the P coordinates are x1, y1, and the Q coordinates are x2 and y2. Okay, so y2 minus y1, that is 10 plus 5 over x2 minus x1, that is negative 30 plus 5, right? So it would be 15 over negative 25. In the lowest form, it would be negative 3 divided by 5, right? Now let's find out the last slope, that is the slope of S and R. So the S coordinates are x1, y1, and R coordinates are x2 and y2. Okay, y2 minus y1, that would be 10 subtract 25 over x2 minus x1, that would be 20 plus 5. So it would be negative 15 over 25, and that is again in the lowest form would be negative 3 by 5. So we can see that the opposite slopes are same. So to check that a quadrilateral is a rhombus, we have to do two steps. We need to find out the length of all the sides, and the length of all the sides must be equal, must be same. And the second step, we have to find the opposite sides must be parallel. We have to find the slopes of the opposite sides, and it must be same. I hope you understand how to represent a quadrilateral, a rhombus. If you want to watch more and get updated, then please subscribe to my channel and hit the bell icon for the latest updates. Thank you.